Hi, we're Team 21, and our project focuses on analyzing sustainability trends across the globe. It's important to take care of our planet and reduce carbon emissions, especially with the booming technology in today's industry. We want to highlight countries that are adopting best sustainability practices, as well as those that are struggling in these areas, and really highlight what background factors may be causing inhibitions or uh, improvements in these areas. We utilize mapping for visualization of our clusters that we obtain, and then analyze religion and policy as well as GDP as our primary background factors. We use Trilema data as our background for this project, and the Trilema indices are calculated using energy equity, energy security, and environmental sustainability for a country. We collected the 2020 reported indices using a Selenium web scraper, and then for 2000 to 2019, we collected relative percentages based on a 2000 100% base score and adjusted the data to become indices. We also collected GDP, religious composition by country, and sustainable governance indicators across 128 countries.
Okay, so the first analysis that we decided to do was take the three aspects of the trilemma score for every country that we had from 2000 to 2020 and use a linear regression to predict the scores for the next 10 years. The majority of these lines fit rather well, and we calculated R values to measure the accuracy. The ones that we did not fit well, we analyzed with the decision tree later that will be later discussed. From this, we moved on to use k-means to cluster our data. The first clusters that we made were for a graph of 2000 versus 2030 predicted trilemma scores. This showed us which countries had high, medium, and low trilemma trends and allowed us to analyze these countries by GDP, religion, and continent. From this graph, we can see that there's an extremely high correlation between GDP and cluster 0, which is the cluster that had relatively high trilemma scores. As well, we can see about 80% of cluster 2 is in Africa, which is the cluster with relatively low trilemma scores. And we see similar trends with the religion data that we have. In addition, we analyzed the SGI scores, which takes into account environmental policy for the countries in each of these clusters, and found that the trends followed as we expected them to. The next thing that we did was a k-means to cluster our data from 2020 trilemma score versus the slope of the trilemma score from 2000 to 2020. From this, we saw which countries were prospering in the areas of sustainability and climate, and which countries had been stagnant or fallen short in these areas. This allowed us to examine each country more objectively, removing the bias of a head start where a country with ample resources might have higher scores in 2020.
So as Rachel mentioned earlier, we ran a decision tree in random forest for a regression algorithm in order to capture the countries with non-linear behavior in their historic trilemma datasets. We identified these countries by R-squared values below 70% when fitting to a simple linear regression model, again, as mentioned by Rachel earlier. Our intention was to use the 2030 predictions of the nonlinear data to recluster by k-means and see if it yielded kind of intriguing results. But when we were looking at the plots of these countries, we weren't really able to see any pattern in its nonlinearity. The output with the decision trees essentially followed suit. We experimented profusely with tuning parameters, and we achieved some level of closeness for the RMSE values between the testing and the training datasets, but we were never able to get an appropriate R-squared value with the testing datasets, sometimes negative values as well. We decided to move forward without predicting the few countries with non-linear trends, but use decision trees and random forest classification in different ways.
So speaking of that, after running k-means and obtaining clusters, our team ended up running the decision tree classification and random forest classification algorithms. We did this with the goal of trying to strengthen our k-means clusters that we mentioned earlier. We wanted to classify our countries into the following categories. Countries that show a lot of promise in shifting their attitude about climate change, countries that show a little promise, and countries that show very little to no promise. We ran the decision tree and random forest algorithms based on every country's trilemma score average, GDP, religious makeup by population, and their continent. However, we found that classification by decision tree and random forest yielded fairly inaccurate results. For the decision tree, the decisions ended up leading to classifications that were about 45% consistent with another set of data that simply took the top, middle, and bottom 33 percentiles of the slopes of the average trilemma scores for all the countries. As for the random forest, the accuracy was only able to get as high as around 44%, even with constant changes to the hyperparameters. The reason for this is because it seems that it's hard to categorize these countries based on only the GDP and other things I mentioned earlier. So the next part of our results are these interactive maps. The results of the two clustering mechanisms that we did can be visualized with these interactive maps. Rachel, would you mind hovering over each color of the map as I talk about it?
Yes.
Okay. So the first map, here are countries clustered into the highest, middle, and lowest average trilema scores over the past 20 years. Below it, in the second map, it shows countries clustered by their trilema score growth rates, with a total of 3 clusters that separated the slopes by each country into bottom, middle, and top percentiles, 33 percentiles of slopes. There are some really cool observations that can be made here. Like if you look at the top, both of the graphs, like you can see the fact that a lot of the countries in the Western Hemisphere seem to have the highest trilema scores, but are in the bottom and middle thirds of the trilema score slopes.
So overall, the outcome we discovered as a result of completing this project were significant since our group reasonably predicted the change in countries' sustainability aptitude over the next decade. This newfound data allows for us to determine the countries with little to no growth in sustainability practices and consequently formulate like a plan that will accelerate their sustainability growth. And these plans will be the result of analyzing the consumer attitude towards sustainability in these low-performing countries and determining how consumer participation in like using clean energy can be increased. And really overall, our main goal for this project was to determine which countries show the greatest sustainability growth rates within the next decade. And using linear regression, k-means clustering, decision trees, and random forest classification, we did just that.